Hi everyone. In this video, we are going to be talking about graphing logarithmic functions. But first, I wanted to clear up a little bit of a mistake. Not really a mistake, but I just forgot to include something last time when dealing with the definition of log functions. And let me restate this definition. For any numbers a, b, and c, where a and c are greater than 0, and a is not equal to 1, then we have log base a of c is equal to b if and only if a to the b is equal to c. And I forgot to include the part where a and c are greater than 0, or they're both positive, and a cannot be equal to 1. Okay, those are two very important parts of our definition for log functions. So I apologize for any confusion. I updated the video by putting something in the description about that. But if you missed that for some reason, hopefully this clears that up. All right, so let's go ahead and graph a few of these. So here we have f of x is equal to log base 2 of x. All right, so we have to be careful when choosing our values of x here, okay? We want to choose values of x that sort of make sense with our situation, okay? So let's just start by looking at x is equal to 1. So if we have log base 2 of 1, we have this is equal to b. Remember, a to the b is equal to c if and only if log base a of c is equal to b. Okay, so that means that 2 to the b is equal to 1. Well, that means b must be 0 because anything to the 0th power is 1. Okay, so we have then 2 to the 0 is equal to 1. That makes sense. So we can plot the point x equals 1 at 0. Okay. Let's try maybe 2. Let's try 2. Okay. At 2, we have log base 2 of 2 equals b. All right, now remember, we want to have 2 to the b equals 2. Well, here b equals 1. All right, so we know then at x equals 2, we're going to have f of x is equal to 1. What about 3? Actually, let's do 4. Let's not do 3. Let's do 4. Sorry. At x equals 4, we have log base 2 of 4 is equal to b. So we want to find 2 to the b is equal to 4. And here b is going to be equal to 2. So at x equals 4, we're going to have f of x is equal to 2. Okay, and you can keep going. But let's go the other direction. Let's see if we can get closer to 0. Let's try 1/2. So here we have log base 2 of 1/2 being equal to b. Okay, this means that 2 to the b is equal to 1/2. So here, b must be -1. So 2 to the -1 is equal to 1 over 2 to the 1, or just 1 over 2. So at x equals 1/2, we have that b is equal to -1, or f of x is equal to -1. Okay, now let's try maybe 1/4. So we have log base 2 of 1/4. All right, and this is equal to b. Okay, so we have 2 to the b is, sorry, that's not a b. 2 to the b is equal to 1/4. And we can have b is equal to -2. B is equal to -2. All right, so that means at x equals 1/4, we have f of x is -2. So what you're going to find is the closer and closer you get to 0, the more and more negative this value is going to be. And it's not going to be defined at x equals 0 because we said that c has to be greater than 0. So that means that we're going to get closer and closer and closer, but we're never really going to touch. Okay? And the further off you go to the right here, the less steep this graph is going to get. Okay, so this is going to be the basic shape of this graph. Now let's try one more. All right, what if we said we have g of x is equal to 1 plus log base 3 of x? Okay, what if we chose 1/9? Okay, well, in this situation, we would have log base. Let's okay. When we're doing this, let's just focus on the log base 3 of x part. Okay, we're going to deal with this plus 1 here in a minute. So if we have log base 3 of 1/9 equal to b, that means 3 to the b is equal to 1/9. So what value of b would make this make 3 to the b equal 1/9? Well, we would have b equals -2. So we'd have 3 to the -2 equals 1/3 squared, or 1/9. All right. So if we have b is equal to -2, okay, that means log base 3 of 1/9 is equal to -2. So we would actually have 1 plus -2, and so we'd have -1. Okay. So at x equals 1/9, so really close to 0 here, we're going to have -1. Okay. All right, so let's try maybe x equals 1/3. So if we have log base 3 of 1/3 equals b, that means 3 to the b equals 1/3. So what value of b would give us 3 to the b equals 1/3? Well, here that would be b equals -1. So we have 3 to the -1 equals 1/3 to the 1, which is just 1/3. So if we have x equals 1/3, then we have that b is equal to -1. So we have 1 plus -1, which is 0. So at x equals 1/3, we have g of x is equal to 0. Okay, let's try 1. Let's try 1. So here we have log base 3 of 1 is equal to b. So here we can do 3 to the b is equal to 1. All right, so that must mean that b is equal to 0, because anything to the 0 is 1. All right, so since b is equal to 0, that means log base 3 of 1 is equal to 0, and therefore we have 1 plus 0, which is just 1. So at x equals 1, we have g of x is equal to 1. Now let's try 3. So we have log base 3 of 3. All right, so that'd be equal to b. That means 3 to the b equals 3. So here we have b equals 1, because 3 to the 1 is 1. Or 3 to the 1 equals 3. I'm sorry, not 3 to the 1 equals 1. 3 to the 1 equals 3. All right, so we have 1 plus 1, and we'll get 2. So at x equals 3, we get 2. Let's try 9. Here we have log base 9, or log base 3. 9 is equal to b. So 3 to the b equals 9. And therefore, we have b must be equal to 2, because 3 squared is equal to 9. So we have 1 plus 2, and we get 3. So at 9, we get 3. I think that's 9. 2, 4, 6. Yeah, 9. Okay, so what you'll notice is that this gets really steep here at the beginning, and then it progressively gets less steep the further off we go. All right, and as you get closer and closer to 0, it gets infinitely more and more steep. Okay, so this is the basic shape of your logarithm graph, and hopefully that makes your graphing a little bit easier.